And we are ready for our next speaker. So our next speaker is from Lablicate, Matthias Mailänder. He's been similar, as I said yesterday, MSD has been journaling our experience. Well, he's been kind enough to present over the last couple. Allotrope connects as an open chromatography product to let folks know all about how ASM is more and more part of his product. And today we're going to get the latest update on the Lablicate story.
Yeah, thanks for the introduction. I'm going to show Allotrope Web in a minute, but just a quick reminder, OpenChrom from Lablicate is, this desktop applications with lots of buttons in it. And what we also do, we like lots of options how to export your data. Everything that is text-based basically is open source. We donated most of the source code also to the Eclipse Foundation. So the X one marked with an X are, for example, XML files. So we are really into open standards, and but we also have to cover the other side. Like you need to open the proprietary vendor data. This is also what we do. We allow you to download the plugins you need to connect to read the data files from your specific instruments. For example, if you don't want to wait for Edge and OpenLab release in fall, you would click these and go ahead and have Allotrope already. You see, for us, Allotrope is just another vendor, just another one where we allow a data export into. And in this list, all the major players are there because this is driven by popular demand, basically. We don't usually change log a lot about these converters, but they're constantly improved. For example, the Shimatsu Lab solutions for GC and LZ were recently released. And there's also something coming up from TopWork. They have an HDF5 container, and they gave us their full specification, including all the mathematics to calculate the results. So that is another way to make converter development go from months to weeks. I'm just saying, hint, hint. So, and also, I know Waters is very popular here in the pharma domain. So of course, we also support that. So go ahead, try it out and give us your feedback. And actually to come back, we heard about manufacturing methods already. And now actually we use the same term. We call it process methods. And it's basically a way how to process your data, like in steps to take. And this one, click on these, you can parameterize them and set them up. And this one is a simple model where we do a peak detection and integration. Then we take the 15 highest peaks, and then we run a library identification. And we heard yesterday from NIST. We are also a NIST distributor. They have a really large GCMS library, and we can leverage that from within OpenChrom. But actually, I didn't want to show so much of the desktop variant because actually we wanted to put in a browser now. It's a reduced interface. It's a simpler one. So actually, I put in some stuff here. You can put in a URL. I'm using local data here. The strange.d folder and data.ms, the cracks already know. I'm putting in a legacy ChemStation file in here because the data migration data, that's also a huge topic for us. And you see the process method that I just shown you. I also put that in here. I push the button, and actually then we just wait. And I can also you can also see, okay, it's already finished. But what's actually done here, what you're seeing this, I showed last time our cloud converter, and this basically builds upon it. It's just we have two Docker containers running here. In parallel, there's one that's doing the heavy lifting that was showing the logs that something got calculated. And then there's the UI one, and that's what I'm going to show you now. It's basically a web editor. It's a React application. And I will also quickly show you why this is interesting from here. What you can see here, we have full spectrum GCMS file. It's not just the tick value. Every data point is actually a full spectrum, and we just generate a tick from it. And the idea here is that allows us to do deconvolution of peaks. You see these peaks are overlapping, but we are using MS, so we can deconvolute them. And I also need the full spectrum, because what you see here on the left is a database hit table, again from the NIST 23, a results table basically, and shows the spectrum from the chromatogram and the reference spectrum against it to match. So I need the full spectrum. The total ion current here would, it could still show a pretty chromatogram, but we couldn't really process it. So we are going for the full data. We are not parsing text reports. We always want to get the hard data. And now the idea is what you do with this. What our customers asked us, they wanted to have like an interactive report, and basically that's it. Maybe you have internal customers, they don't want to see just the first hit. Maybe they want to see everything, because they have a lot of domain knowledge. They know best, maybe even better than the analytical chemist, what's inside the sample. So they maybe it's the fifth query here. Or another point is actually, I said the other way around. You have an external customer. They want to see the chromatogram, but they're actually not chemists, so they actually have no idea what's this about, what's toluene, and why is there a D8. So actually, my colleague created a small little button for me. So we have structured data here, so of course we can put it in a chatbot here that generates some knowledge. You could also think of a rack here with internal company data that could be queried. In this case, I just used ChatGPT, and I instructed it to use layman's terms and to make it a bit simpler. So that's way. Also, but also going to show you. Part of my job is actually to take things apart. So I'm doing this also now with my own application here. So let's do it again, but in developer mode. So I press F12, and let's see what happens here. Needs to process it a bit, but it's actually quite fast. So, okay, I will sort this by, we are after the JSON file, and let's take the biggest one first. The request is here to an API input and what you want to do with it. We are interested in the response. And you see, oh wait, we actually built all of this around the Allotrope simple model. Every JSON in here, this is a React application, it's a JavaScript application. ASM uses JSON. JSON is JavaScript object notation. So, it fit right perfectly. And it also helped to reduce development time drastically. There's always the idea, how do we serialize this data from Java into JSON? Of course, you can come up with something, but why not take something that's already there? And so that's basically what we did. And you can see here, actually everything in here, also the library matching that you saw it. And maybe you now see the full picture why I pushed for all of these small elements, these additions that we recently added to the standard. I'm not a huge fan of vendor additions or proprietary fields or so. So we just submitted everything as a standard. People looked at it, gave us some hints what we can improve, and JSON schema and some manifest that where people have put thought in, that also really helps like the front end developer to do this a lot faster. Okay, then there's also another one. It's just a single mass spectrum in here. And this is a question to the audience. Why do I need another single mass spectrum here for my application? It's chromatogram stuff, but any ideas? The comparison spectrum. I need to query the database for the comparison spectrum to display that. So that's, again, another Allotrope simple model object that gets queried, and we get there. So that's basically one thing. What I also noticed, I mean, this is also a pretty interface. We showed this at a trade show. It looks good on a large screen. And what I also think, I mean, I have big pharma here in the audience. I see this also as a gateway drug to Allotrope. Not everybody is into file formats and into open file formats. For them, most of them just want to share their files, open their files. They don't want to get into the technical details. Or what I usually get, what people say is, yet another open standard, or let's wait for adoption first. That's also a thing that's a bit problematic if you want to get adoption. So, I mean, this is something you could use this. I mean, you don't have to look at the Allotrope stuff. It just hides it in a nice interface, I guess. So that's basically what we hear. Then what we also hear is the Allotrope certification progress, or the validation program. And yeah, we when I heard about it, I asked Ernon immediately if I could test it, because I always wanted to do the validation. And I also remember Vinny talking about last time demanded that this is important. And I fully agree. I just never got into it. I never really knew how to best validate. And what this is, it's actually, for a developer, it's something that you're used to. It's a continuous integration pipeline. I mean, you see some steps they run through. In this case, everything is green, everything is fine. So no trouble here. That actually makes it look like that I nailed it first try. I'll be honest. I click here. Yeah, I didn't. So, of course, it's really easy to make mistakes when creating ASM. And these mistakes can actually be, maybe it's a missing field, maybe it's an instrument serial number that somebody said is mandatory in this format. Then you have to add this field to comply with the standard. So that's easy, something to forget. That's also easy to get something subtly wrong. And this causes friction. And we are now deploying this into the chemical industry, and they really demand for this standardization. And of course, it makes implementation a lot easier. If we deploy it and we know it validates, then there's not multiple attempts to do it. So then there's also something you may wonder, actually, how did we put, like, how do we squeeze this scary chromatography desktop tool here that looks a bit, like an integrated development environment? How did we put this into a Docker container? That seems like a project that could fail. And actually it didn't, because this was planned all along. This application is actually 10, 15 years old, and we use Eclipse RCP. And the idea of Eclipse RCP always, they promised the convergent UI, so everything should work on the desktop, but also on the web, because at that time the hype topic was not AI, not yet. It was multimedia was, I think, already gone. The hype topic was Web 2.0, so everything had to go to the web, and so this was planned all along. This is actually a talk of my boss at EclipseCom, and it is actually from 10 years ago. So he already prepared a small demo. Always make sure that we separate logic from user interface, so we can easily replace it with something else. So that was also long. So now a short message from our founder. I think we can take it from the break time, when you would be okay with that. I'm just kidding. I just wanted to see his face. And yeah, maybe also, I mean, this is of course built upon something. If you want to learn more about the desktop applications, I don't want to repeat it here, because there was already a talk about it, so you can just watch that also on this very same channel. And what this thing last time, which was the cloud converter, which was basically similar technology, but it had no user interface. It could only convert files to ASM and ADF. But so this is a continuation of it. If you're interested only in the cloud converter, maybe look at that. And otherwise, I'd say, yeah, kind thank you all for listening. Press the like and subscribe button for more Allotrope content, and see you in the next one.